everyone. My name's Peter Hansons, one of the organisers of the Sydney dbt Meetup. We've got a bit of a Australia and New Zealand combined meetup almost today with two speakers from each country. So that's really exciting news. So we've got James Weakley, who's becoming a bit of a regular. He's the CEO of Omnata, a reverse ETL startup based here in Australia. And he's going to be taking us through making a macro when and how to build and distribute reusable transformation logic. So I think that's really going to be great because as we're all getting better and better at dbt, it's good to be able to sort of contribute back to the community. And so really appreciate James taking us through all of that today to sort of teach us how to do that. That's great. And Chris Jenkins from across the ditch, Data and Information Manager at Trustpower. His talk title is Data, What Should the Humans Do? So that's going to be really cool. But today we're actually very happy to have the company of a few dbt Labs folks from here in Australia. So we've got Pat Cairns and Lee and Kelly. So welcome everyone. I think we're going to do some introductions just to introduce the team here from dbt Labs here in Australia, just in case you've got any questions in regards to dbt Cloud and all of that sort of jazz. So take it away.
Hey, thanks, Peter. Hey, everyone. My name's Lee. I joined dbt Labs earlier this year along with Callie. We've both been working in the Australian team for a few months now. So we've maybe met some of you on the call, but if you're looking and want to chat to someone from dbt Labs locally, feel free to drop a chat in the StreamYard chat section or reach out to us. And more recently, we've been joined by Pat Cairns as well, who's made a bit of a big trip around the world from New York to Auckland to Australia and back and forth multiple times to finally land in Melbourne. So there's three of us now representing dbt Labs in Australia and APAC. Hopefully be a few more people by the end of the year. And yeah, just nice to meet everyone. I won't take up any more time, Peter, so I'll hand back to you.
Yeah, well, thanks for joining us today, and really looking forward to sort of hearing from you at future meetups. Thanks so much. Cheers. Okay, cool. Well, on to our first talk of the day. We've got James Weakley. I'll just quickly add him to the stream and then add his slides. So you've taken us through dbt-ML preprocessing package before, I believe, at a dbt office hours, haven't you, James?
Yeah, that's right. So previously, that talk was really focused on that use case, which was machine learning preprocessing. This talk is more about the process of creating macros, and I'm using the same library as an example, but this talk's not really about machine learning in particular. It's more about dbt in general and how to work with macros. So
yeah, sounds cool.
Bit of a long title. I didn't realize how long it was until I heard you pronounce it just then, but it's a short and snappy talk, hopefully with some questions from people at the end. The thing I like about this meetup is that it's nice and interactive usually, so keen for people to let me know their thoughts and we can chat.
Yeah, so before I leave you to it, definitely, as James mentioned, feel free to sort of ask some questions on YouTube and we'll pull them up at the end of James's presentation. Also, feel free to say hello and tell us where you're from. I think, with these online meetups, it's difficult to have that hallway track happening. So it's always great to just kind of engage with one another and say a quick hello. So yeah, I'll definitely be doing the same. But without further ado, take it away, James. Thanks so much.
Okay, so let's get into it. A little bit about me before we start. My background is mainly as a software engineer and a systems architect. I moved into the data and analytics space maybe about 6 or 7 years ago. I've been an open source contributor for a long time, pretty much most of my career. And I've been a dbt user for, at least in dbt terms, a pretty long time. But I'm now running a local tech startup called Omnata. We're a dbt labs technology partner. I think I can claim that we're the only technology partner headquartered here. I'm sure someone will tell me if that's wrong. But just a quick plug for Omnata, which is my day job. I started that company by asking, why can't cloud platforms talk directly to each other? And really the modern data stack allows us to really rethink how we do integration. The old generation of tools were very big and heavy and expensive and sat in the middle and really got in the way a lot of the time. Our two products help you push data out of your warehouse into your apps quite easily, and also to live query your warehouse from your apps. So we've been going for about 12 months, getting a little bit of traction sort of locally and abroad, and a range of customers from different industries, the likes of the West Australian government to US-based companies like Vonage. And we're really expanding our supportive combinations, just following that principle of creating integrations that talk directly. But you're probably not here to listen to me talk about Omnata for the whole time. So what we're going to cover in this short talk is two things at once. We're going to talk about macros and we're going to talk about packages. And really a package is just a way of distributing macros outside of your own project. So the reasons for creating a macro are mostly technical. The reasons for creating packages are mostly social, but both are very important. And I guess to summarize, macros are dbt's way of creating abstractions. In other words, taking something complicated or detailed into more of a black box that has a simple interface. And really, abstraction's key to good engineering, because all complex systems need it at some point. Our brains can't really concentrate attention on lots of complicated things at once. So getting good at abstraction is key to being a good engineer. And I guess you could say then that being good at macros is key to being a good dbt engineer. So, and the other part, macros, they're really dbt's way of allowing its community to pool resources in a way. So if somebody's gone to some effort in a particular area and solved it well in a reusable way, it can save other people a lot of time. So it's kind of a productivity boost as a network effect within the community. And because dbt's packages are inherently open source, creating one makes you an open source contributor, which is a good thing. And I always think the sooner you make your first open source contribution, the sooner you get into the habit of sharing your work, which I think these days is really important. And definitely don't wait until it's perfect, because other people don't do that. I certainly don't. So all code has bugs, but please do share your work, and I think it's good for everybody. So dbt macros, I guess to summarize, they're for generating SQL that does something that you need. So let me just jump into the docs for a sec. Why you should build a macro is pretty well summarized here. So it's using Ginger, and it's good for a bunch of different reasons. I guess one of the mistakes I make, the mistakes I see other people make, perhaps including myself initially, you sort of see that Ginger macros are like a mini programming environment. So it can be tempting for the actual transformation work to creep into the macro, but really the macro is for generating the SQL that does the work, not for actually doing the work. So it's perfectly fine to to run a query, loop over the results, as long as you're doing that in order to generate another query, not to do things like start adding up numbers and things like that. As for when you should write a macro, I think it's often best just to write in SQL and then look for opportunities to roll parts of it up into a macro. So in software engineering, this approach is called refactoring. And I would suggest maybe if it's not something you consciously think of at the time, it can be helpful to schedule some recurring time, like maybe once a month or once a quarter, to actually review some of your bigger, the heftier parts of your dbt projects, and maybe look for opportunities to break parts of it out into a macro. There's some really good advice further down here on how to write db tonic ginger. So just some principles. I really like the first one because I think people can sometimes go overboard with abstraction and kind of abstract something to within an inch of its life, and then it actually becomes harder to read by others. So I'm in favor of a little bit of repetition just to keep things, not spread out over 10 files, but in one spot. And I'd suggest reading this whole guide really. But what I'm going to do now is actually step through the whole process, what that looked like for me, start to finish, with actually building a package. So a couple of years ago, I was spending a lot of time in Snowflake and experimenting with what sort of workloads it could run. And I was documenting these experiments on Medium. And this one in particular was quite popular. It was an article on how to do feature engineering in Snowflake or generally just in SQL. Because at the time, people would use SQL to get the data into the basic shape they needed. But then if they wanted to do machine learning, they'd take it out into Python or R. And the assumption was that like encoding and scaling the numbers in the data set was more of a programming task. Now, I'm not really like a stats whiz, but I do understand kind of the algorithms that they use. So when I got curious about what they were actually doing under the hood, I found that they were mostly just applying some formulas over some aggregations. So, standard deviation and average and that type of thing. And I realized how easily they could be expressed as SQL. So I went through essentially all of the pre-processing functions from scikit-learn, which is a Python library, and just wrote a little snippet that showed how you could achieve the equivalent thing just within the database. And I mean, most of it was pretty terse. It was a lot of mins and maxes and that type of thing. Nothing particularly unusual. One of the things I concluded at the end of the article was that the practicality of it, there was a bit of boilerplate involved with writing these queries. But if they were being issued by an application or a code library, then it wouldn't be a problem. And of course, it was later that year I would learn about dbt and then realize that dbt macros are kind of the exact answer to that problem. So the goal then became, how do we go from just kind of a snippet of showing someone an approach to giving them something that they can just plug their own data straight into? And so that's what we're going to work through here. So if we focus on the max abs scalar, it's not a fitness program, it's a scalar that scales each feature by its maximum absolute value. So for example, if you've got a column of numbers, the largest number in the column is say 293, it's going to divide every number in that column by 293, which means that in the new scaled column, every number is going to fall between -1 and 1. So that's really all there is to it. So if I just jump over to the code, now this is a whole table query. Sometimes macros can generate just a single column, but in this case, there's a few CTEs and things involved, which kind of meant it was going to be easier to just generate the whole table. So this macro is meant to be used to build an entire model. What we do is we let the user pass in the name of the source table, which will be a reference, a list of columns to encode or to scale, and also another list of columns to bring through from the source table. So the first thing we do is a bit of error checking. This is just a nice thing to do. If someone passes in the wrong type of value, we give them an error that is a bit more meaningful. Then we let them pass in an asterisk for the include columns. If they do that, then we'll go and actually fetch the names of all the columns. That's just another convenience for the person using it.
Sorry, James, would we be able to quickly zoom in a little bit further on that code?
Sorry.
Yeah, no worries, mate.
I don't think I've ever zoomed in on VS Code.
Control plus. Yeah, that's good.
Okay.
Yeah, really good.
Cool. Thanks. And so we've got the list of columns. Now this is the part that actually does the work. So for every source column that we want to encode, they're all scaled independently of each other. So we have a common table expression for every column. All it's doing is calling max and abs to give us a single row, which is the maximum absolute value from that column. And then in the main expression, we put all the source table columns in that we asked for. And then for each of the columns to scale, we just build this little formula. So the name of the column divided by the name of the column from the other table, and rename it as scaled. And that ends up generating, if I show you a test case of, whoops, this is a model that calls that macro. And what it does is it generates this SQL here, which does all of the work, and it pushes it down into the warehouse. So we'll come back to some more details shortly. But what we have at this point is a macro that is no longer coupled to the example that we gave. This can be used on any table now. And so that works, but a good analytics engineer needs to consider more than just whether or not it runs. So questions like, will it continue to work in the future as things change? And how will other people understand it and know what it does? So to answer that first question, how do we know it's going to keep working? We do that with test cases. So a large part of this project is actually the test cases that show that it's producing the right output. So for every encoder that we have, I've got a sample, just a basic sample data set. So if we look at this, it's just a handful of values that we want to scale. And what we're going to do is generate some expectations, and then we're going to compare what the macro produces to those expectations. So because I was porting a library from Python, I've just got a simple script which takes the test data, passes it through the actual Python library, takes the output of it, and then we just commit that as another seed file. So essentially, we have this table here, which is what we consider to be the right answers. These are the values scaled by the Python library. And so what we do with the test cases is we've got our test model, which is taking our input data, passing it through the macro and saving the result. And we're using the dbt utils equality macro to say that table needs to be identical to the table of expected values that we generated. So what that means is if when we run this, we're essentially saying that our macros produce the same result for that input data as the Python libraries do. And the other important question is around how do other people know how this works and how do they use it? So that's documentation. So what we do is for every macro, we have a accompanying YAML file which describes what the macro does and what all of its inputs mean. And we can actually, because that's done as a dbt docs file, we can actually view it as dbt docs, and it essentially shows what all the macros do and some examples of how to use them. So there's one final desirable trait of a dbt macro, and that is that it can run on different databases. So a quick example of that is if I look at the robust scalar. Now the robust scalar essentially does the same thing in the sense that it squashes the range of values down, but it's robust to outliers, which means instead of just taking the average, it looks at the difference between two of the quartiles. And of course, every database engine has a slightly different way of doing quartiles or percentile values. So to make this work across all the different databases, we leave all the common stuff at the top of the macro, which is like the error checking and grabbing the names of columns and things. But then we call adapter.dispatch to generate the rest of the SQL. And it's going to look at which adapter you're using, which is basically what database you're using. And it's going to pick the appropriate implementation of the macro, and it's going to generate SQL that's compatible with your particular database. So the final thing to cover is packages. So you've got a macro at this point, a macro that works. You now want to share it with people outside of your company, or even just to different projects internally. The way you do that is pretty simple. There's the dbt hub, which is a list of all of the registered packages from various vendors and individuals. You can see Fivetran's been quite busy. Here we are here, our pre-processing library. To do that, you just have to go to the hubcap repository, which is under dbt labs, and edit this file, put yourself your organization, your repo name here, and open a pull request, and make sure you've got at least one version tagged in Git. And once someone from dbt labs merges that, you'll automatically appear on the package hub. So to do that, the package repository obviously has to be public. And so you want to make sure there's no baggage left over from its initial use case. So you make sure it's kind of just more of a generic macro with documentation rather than still having lots of models and things from your initial use of it. And oops. That's it really. I have, I think, a bit of time for some questions. I can already see some comments coming in here. Peter's going to join me for question time, I think.
Yep, absolutely. Apologies before. I think my mic was a little bit soft. Yeah, so hopefully this has fixed it and you can hear me properly. But yeah, thanks so much, James, for that presentation. That's awesome. We've got a question, as you mentioned, from David Smith. When your macro produces DB-specific SQL, do you test the behavior as well as the output SQL, or is it the approach of assuming the Python library is correct?
Good question. So the way you should do it is for every database that you support, you would essentially do a full dbt run with targeted at that particular database, so that you're using that adapter, and then do your dbt tests, because you do actually need to verify that the SQL code that's produced for each different database is going to satisfy that test case. So you end up doing, like, if you imagine a CI pipeline, and you've got, say, the top 5 databases supported, you're going to go to each one and do a full dbt run, dbt seed, dbt run, dbt test individually. So yeah, because you don't really know, you could have like typos or wrong assumptions in your adapter specific macro.
Very cool. We have another one from Ray Ho. Should all macros come with seed CSV files like that? I was looking at another package which had integration tests, but no seed files.
Yeah, I don't think it's really a requirement. For me, it was easy to use seed files as a way of setting expectations, but you could, I guess it depends what behavior you're verifying. My tests were virtually like a more of an end-to-end style test, but you could certainly, if you were really confident in what the SQL needed to look like based on what parameters someone passed in, you could probably just take that approach, or you could just create a test model, which is just a view, which isn't really like seeded data. It could just contain sort of synthetic results within the view definition. Hopefully that, yeah. So short answer is they don't all need to come with a full data set to do the testing with. What's my approach to debugging macros? So what I'll do, if it's like, I'll usually do a dbt run and then look at the created SQL. If it's not matching up, I would generally copy the produced SQL into the query editor and then just run parts of it or sections of it until I'd isolated where the problem was. So everyone probably does it a bit differently, but I tend to kind of push it through the macro and then take it outside straight into the query editor to find out where the issue is. Once you work out where you've gone wrong, you go back to the macro and change the relevant part and try again.
Awesome. Thanks, Ali. Last question from Hang. Thanks for the demo. Is it possible to use a macro with a Ginger block? For example, we want to have a macro get data to get an integer value and use it in a loop for I in range, yada, yada, yada.
Yeah, you can definitely nest the macros, and you can, if you're using, like, if you've got a model and you've got a section of Ginger within the model, you can call macros. It's all quite global in that sense. You've got access to whatever macros have been declared in the project, plus whatever you've imported through packages as well.
Thank you so much. Well, that was, we had lots of questions today for your talk, James, which is usually a very good sign of a wonderful presentation. So really appreciate you taking the time to put that together. That's awesome. So thank you so much, James. With that, we will cross over to Chris. And welcome you to the live stream. Are you sharing your slides by any chance, Chris?
I am just about to hit the button.
Fantastic. Well, so Chris, you're from across the ditch.
Yes.
Yes, should have thought of a few more Kiwi jokes to pull at you, but yeah, just too busy at the moment.
Well,
But
no, you couldn't bring me down with any today. I've just seen the result of the sevens semi-final, and very happy to be on this side of the ditch at the moment.
nice one. Cool.
Brilliant.
So your talk's like data, what should the humans do? So I guess tell us a little bit about that. What's that all about?
Yeah, of course. This is something I've been thinking about for the last, probably the last year or two, actually, as I've realized how smart the machines are getting. And I'd say for a lot of people in a room like this, we're likely to be reasonably technologically engaged, which I guess as a futurist, I'm always looking to see what's going to happen, what's going to impact the stuff that I do, the stuff that I care about. So I've been developing this set of thoughts, and I've built some stuff which I'll be sharing as well. As you'll see on the screen, I'll be talking a little bit about Tangata, which is a tool that I've been working on for some time. But this is going to be mostly philosophical. I like to really dive in deep to kind of talk about this is what should we do? How should we be spending our time? Where do we create some really good value out of the humans that we have working in data, all the people on this call? So that's kind of what my subject is.
Awesome. Well, so you lead the data management capability at Trustpower, so you're well positioned to do a talk on this. So very much looking forward to it. So I'll let you take it away. Thanks so much for joining us, Chris.
Brilliant. Thank you, Peter. So thank you for jumping in, and please start stacking up questions. I've got a little bit to say, and I'll be showing a little piece, like I said, of a tool that I've worked on to address some of the issues I've uncovered on this journey. And to start out, I have a quote. As said, I'm from New Zealand, and we've got a Māori proverb that to anyone that's ever worked in public service in New Zealand, it's one they'll be very familiar with. But I've got a translation that will make sense in any context. If the heart of the flax plant was removed, where would the bellbird sing? If I was asked what was the most important thing in the world, I would be compelled to reply, it is people, it is people, it is people. The words in Māori are he tangata, he tangata. But there's actually quite a lot of meaning beyond what an English translation of this thing can actually describe. What's the most important thing in the world? Tangata is actually something that is much wider than just the humans that I know. It talks about another concept which they call whakapapa. It's actually the group of humans and their ancestors and their descendants, which is a much, much deeper concept than just a group of people. I took this photo at dawn on Anzac Day of this year. Hey, this is still relevant across the ditch. This is Mount Maunganui Beach. Awesome place to work. If you ever want to work here, give me a call. And this is about 3,000 people gathered together to celebrate something that was really big and really important. These people are not here for anything for themselves. They are there for tangata. They are there to celebrate the people that came before us who gave a great sacrifice and were thinking of us while they were doing so. They went to war for their tangata, the people around them and their descendants, and we are going to remember them as those people who gave that for us. This is the depth of meaning behind this proverb. It's not just the most important thing in the world is about people and their ancestors and their descendants. There's a lot to that. So why am I talking about this in a data engineering forum? So in data, it's really easy to get deep into the technical. It's really easy to get excited by, here's these cool macros and this cool lineage and all of the stuff we can do because we've got amazing tools. Isn't that cool? How could we do this better? What VS Code extensions do you use? But it's sometimes easy to lose sight of what we're trying to achieve here. What's the value that we're providing through our existence? And to jump back to my subject, what do the humans do? I've just thrown an Omnata logo on here for you. These companies are coming for the jobs that we have been doing for the last decade. We've got a whole stack of tools down the left-hand side there that are coming for the data ingestion that used to be hard. My whole team's job used to be go and get the data out of a source system, create a table in our data warehouse to load it into, and map each table across into that data warehouse and make sure the data keeps on flowing, set up some pipelines to make it all flow across smoothly, set up some logging and reporting to tell us if anything's gone wrong, and make it available to analysts in some sort of usable format. That's all being done by this tool set down the left-hand side here, and it's not hard anymore. If I was to open up one of these tools that we use here at Trustpower and ask it, hey, can you grab my Salesforce data for me and drop it into Snowflake? The only steps I would have to do is log into Salesforce and click the tables from Salesforce that I want. And all of that's just going to suddenly appear in my Snowflake warehouse. I've had to do no wiring for that. It's just going to happen. So the job that my team used to do has been replaced by a dumb machine. And that's awesome because we can free up the human to do something cool. On the other side, we've got a couple of the tools on the right-hand side here. And these tools are getting better and better at starting to provide useful information up to people. It used to be a few years ago, if you wanted to predict the behavior of a customer, you'd get your data scientist to dive in to a data set and spend weeks wrangling it, cleaning it up, getting it all ready, creating a Python notebook or R notebook, depending on your flavor, and run the first scikit-learn algorithm against it, and then run the next scikit-learn algorithm against it, scoring them off, checking your values against each other to see which is predicting the best, the most accurately against your set-aside data set. These tools and others, we've just seen a demo of a faster way to do this stuff. This stuff is getting easier. This stuff, for an example, we use Power BI, and a couple of years ago, I used a new feature that they just released called Quick Insights. You give it a data set and it gives you some interesting information that it thinks where it's found some correlation. And one of the correlations that it surfaced up to me, among a number of others, was customers with a lower date of birth have a higher age. And I saw that and I thought, that's going to get used heaps in every single presentation I do from now on, and I have used it many times. That's what computers do on the first cut of starting to try and predict what humans want to know. Now it starts to tell us more interesting things. And a number of these tools on the right here are starting to tell us interesting pieces of information at the time that we might be interested in hearing them, and they're going to keep on getting better. So what do the humans do? The data's coming in for us. We've got a bit to do at the moment to tell good stories with our data, but the computer's getting better at doing that. The computer's getting better at allowing non-technical people to interrogate the data that we're serving out. So what we need to be careful about in the middle is making sure we don't end up looking like this Tesla charging station, where we have had the world change around us, but we haven't adapted yet to what our role is in this new environment. And over the last couple of years, as I've been finding all of these more efficient, easier, more robust ways of getting data in and then getting data to decision makers out the other side, the thing the humans do is all context. When we've got a set of diverse inputs coming in to our system, the computer doesn't always know how to join those things together. I've got 3 photos on the screen. I took these photos down the South Island of New Zealand. I spent a couple of weeks down there on honeymoon earlier this year, and all of these photos were taken on the same day. One story links all of these photos together very clearly in my mind because I know the context of these photos. At the start of this day, we started in Dunedin. We drove about 3.5 hours, I think, down the east coast at the very bottom of the South Island of New Zealand to get to the big photo on the left. This is a place called Slope Point. This is the southernmost tip of the South Island of New Zealand. It's absolutely beautiful. There's these massive waves coming up, and there's no trees. It's just the grass. All the trees have been blown over. There's just wind, non-stop wind, and the waves just blasting way up in the air. It's about a 20-metre cliff there, maybe 15 metres, for context of the size of all of that. It's about a 10-minute walk from the car park to get to this place, and we drove specifically for about 3 hours south just to get to this point. From there, we turned north. Well, when you're at the southernmost tip, the only option was to turn north, and we drove up through Southland to Queenstown, which was an absolutely beautiful place. We drove into the Hilton Queenstown. The borders were closed, so the Hilton was on special. They gave us a beautiful room. They put us up right up in the top of the hotel looking out across Lake Wakatipu. And they knew it was our honeymoon, so we had this bottle of wine waiting for us, this little card. Congratulations. Everything's just stunning. So I walk into the Hilton, I see this bottle of wine. I sit down on this comfy chair to read the card and looked down at my shoe to see that I brought a present from one of the sheep at Slope Point. And I'd walked into the Hilton. I'd had someone take my bags up for me while I was treading sheep poo across the carpet. So the context for the story is one that a human could never have figured out, but there is emotion in here, the emotion of standing at the left-hand side of these 2 huge basins, this massive bathroom at the Hilton, washing sheep poo off my shoe in this basin, and just thinking of how many people would be coming into this place and finding it spotless that would have no idea that I'd sold it in this way. Humans create context. Computer could never tell you this story, but through knowing how the different parts fit together, this is what the human does. Now's the scary part of my talk. We've got some really smart people on the screen. Ralph Kimball co-created the first commercial graphical user interface working for Xerox. He went on from there to found the industry we're in, essentially, the data warehousing. Bill Inmon, followed by Dan Lindstedt, have kind of taken their own approaches in the same space. How do we take our data? How do we create value out of this? In Kimball's books, he talked about why he took the approach that he did. I'm going to talk to that approach that he gave. I'm recycling some thoughts, I'm adding some of my own. But I'm going to take this from a perspective of the most important thing of the world in the world is people. How would we design our data? And how do we use our humans to give context to our data? And particularly using Snowflake. We've got cool tools. You can take this, you can apply it to BigQuery, you can apply it to Redshift, you can apply it in Synapse if you like. I just think Snowflake is cool, and Kelly's on the call and it'd be hard to break her. So first off, Ralph Kimball talked about the star schema model. One of the reasons he built that model was the reason of cost. So picture the scenario, you're in the late 80s. You buy hard drives in kilobytes and even a couple of megabytes if you were really splurging. So the storage of data was an expensive thing. Probably single-digit megabytes would have been a standard hard drive when he was putting together his thing. So if you were to pull together a data set, and let's say, because of the context of my last photo, let's say I wanted to understand our customer base across the country, and I wanted to understand Invercargill in particular, closest city to where that first photo was taken. So I want to understand for energy use. Let's go a month, the month, how many units of electricity they used that month and the city they're in. So we've stored 1st of the 1st, 2021, they have used 500 units of electricity, and Invercargill is their city. But we've got 10,000 customers in that city. So we've had to write the word Invercargill 10,000 times. So if we can just store that once over in a dimension over to the side here, and it's, say, city ID number 7, store the number 7 in our primary fact table with month usage in number 7, then we've saved our storage cost quite significantly. The second reason he discussed star schemas, he talked about performance, because he was comparing this with the transactional databases at the time, and still how a good normalized transactional application database should work these days, where everything is broken out into all of these related tables with their primary foreign keys, and it's all designed to be updatable as quickly as you can. But that doesn't lend itself well to being able to analyze how many sales have we made this week, how many sales in the pipeline right now, these sort of aggregated things. So in effect, as he proposed it, aggregating things up makes a lot more sense than querying it from all of these dispersed tables. Just to address these first two, when he talks about cost, that's not a thing anymore. We're spending $25 a terabyte a month in Snowflake. It's essentially free to just put whatever data we want in there. That's not a thing we have to worry about anymore. So with that constraint removed, when we're looking at a star schema and thinking, can we just make a big table for all of this? The answer to the performance question is actually, is it faster to join something or not to join something? To which the answer is going to be not to join something. Let's just query the data, get it out. The other thing on that cost point, Snowflake actually essentially only stores the word Invercargill in our fictional example only once anyway, because it's compressing the contents of the column. So it's essentially done the same thing as the dimension. It's only taken up the space of date, number of units used, and Invercargill once, and every other row in this is just going to store ID number 7 or whatever it uses internally. So we haven't even used that storage anyway, despite it being so cheap if we did. So for these two reasons, I'm not saying that it's a bad idea to consider this approach, just that the original reasons why this approach came forward are not necessarily requirements for building a data warehouse anymore, which brings us to understandability. And this is where we get into humans. If you've got a human that has been dealing with Excel for all of their commercial life, and we're wanting to help them get into the dbt world, what's going to be the easiest sort of data set for them to understand? And this starts to become very personal. And I still believe there's a very strong place for some star schema stuff, but I'm pulling this up specifically to challenge how we build things. Can we do things better? Again, I've given this talk in a non-DBT user context. So for many of you that are already using DBT, already in this way of thinking, it's not necessarily going to be new what I'm sharing, but you may be able to take things from this and use them in spreading the case across your organization to widen your reach and things like that. So I hope this is still useful, and I've got some cool stuff at the end as well for those that are already in the ecosystem. I'd say most of you have probably seen something like this before. It's a data maturity model. And if you've ever been in a contractor or partner selection process for your data warehouse, you would have been handed something like this by at least one of the vendors you deal with, that are going from, you are a repeatable and you should be an optimized, we will help you, and here is the big quote for what it will cost to get you to optimized. We went down a path a little bit like this. We focused very heavily in our initial Snowflake implementation. We did use dbt. We came across dbt a couple of months in, and we switched to it quite quickly. We used an approach along the lines of Dan Linston's approach. So we went Data Vault early on. This is where it gets scary. Again, Data Vault's awesome. It's a great way of joining together the whole business and creating something that's absolutely bulletproof and can handle any possible future change. Both of these leaders chose this approach for 3 reasons. The first is invest in planning. Let's get some workshops going. Let's get all of our decision makers in the business together in a room and figure out what the important things of our business, what are all of the nouns of our business, how can we map those together, how do they interrelate, what joins to what joins to what. Let's get that whole big picture of the business sorted out, and then let's start building some of those as tables, pull it in from the various sources. The second thing they did was create resilience. So we've mapped out, we've got these accounts and customers and services and products and all of these nouns that we've pulled together that we care about. Now, in our data model, everything's a many-to-many join because one day it could be. So they create a data model that can handle everything that could possibly happen in the future. So in Data Vault modeling, you've got hubs. Hubs are the nouns, and you've got a link, which is the table that sits between every hub join, hub to hub. It goes hub, link, hub, because even though any given service, an electricity service that we provide, can only currently be billed to one account, one day in future we might allow it to be billed to multiple accounts. So we should make sure that the model can handle that, which is great to make sure that you can handle that. Having an outdated data warehouse is not worth having if you can't adapt to that change. So this is a great way of doing it. The third is integrate everything. So because we've put all of that effort into mapping out, here are all of the objects of our business. We've got a customer object. Let's make sure that every system that captures anything about a customer feeds into this one customer object, so that if we want to understand a single view of customer, it's all sitting on this one hub with its satellites where all of the information is available. Again, really important. These are great ideas. But this stuff's hard. If we revisit after a year of building a Data Vault in my team, we've built a few optimized things, but for the amount that's actually being delivered, that's creating value and creating better decisions in the business, number of things that are going to be inherited to our ancestors is things that give us deep insight into what we actually do around here. We've been aiming for this optimized thing, but we skipped quite a few steps. And this model is not truly a model of technical excellence. It's also a model of the steps that the humans inside our organizations need to go through in order to really be data-driven. We're pretty familiar with chaotic from different roles that all of us, I'm sure, have had in the past. Repeatable, that's something that drives value for people. If you've got a meeting that comes together once a week to discuss the things that a particular important decision in the business, if we're able to provide one set of numbers into that meeting rather than each of those decision makers coming in with their own numbers, we can create value there. And we will create more value by giving repeatable data to every part of the business than we could possibly create by giving optimized data to one area of the business. And the great thing that happens in that repeatable space is if we give that data set I told you about earlier, month, usage, city, if we give that to a meeting that it comes together every week to decide here's what our acquisition strategy might be across the country. Here are the areas that we want to market more to gain more customers. Here are the areas where there is more electricity being generated that we could sell to customers locally there rather than transmitting it other places in the country. That meeting would start to ask questions of the data. And they would start to ask for a little more. Why does Invercargill use more electricity in winter than they do in summer? So they'll come back to the data team, they'll ask that question, and the data team would go away and have a bit of a look, and they'll add a column. The temperature. Invercargill is really cold. So now we've got that fourth piece of information that's fed up alongside the other information that that decision-making team has as they make those decisions each week. So they understand that even though there's not much electricity being used in Invercargill at the moment, it's going to spike in winter as everyone turns on their heaters. So we shouldn't oversell in that area to more customers. We should make good use of what we have. And then they come back with the next question, and the next question, and the next question, and they'll ask to tie this information of what's being used together with rainfall, because we use hydro dams. What time of year does the rain fall in each area? So that's when we're starting to standardize and integrate our data in these areas. And the more tied together the business decisions that actually matter is tightly, the more tightly we can tie those together with the pieces that our data teams are being asked for, not creating because Data Vault's awesome, we're being asked for, can you add this, can you add this, can you add this? Then the more value the whole business can see in this data asset that we believe so passionately is the future of our business. And the future stuff will come. If the team ask me for, hey, can we get the names and phone numbers of the customers that use that electricity, then because I've educated myself, I know New Zealand has a Privacy Act. We really should follow that. Let's get some locked down standards across that and make sure that the question they're asking is actually a valid question, the way that we're allowed to use data like someone's name and phone number. And that starts to pull us up into that governance space that really needs to get there as we grow. So we educate ourselves as professionals, but every one of the individuals that make decisions across our business, we need to hold up this ladder and just give them enough for them to start wanting more. So while these three pieces are critically important, I've talked you through the people side. On the technology side, and this is where this becomes a DBT talk, in DBT, we get to change stuff after it's released without anything breaking. Because we've got this Git-based release process, we can create a user table and then build some stuff that depends on that user table. And then later on, we can say, actually, we want to call that employee because that makes more sense. We can rename it and we can change all of the things that depend on it downstream and release that as a single change through our release process, and it's all just sort of going to still work. To create resilience, the same piece, if our relationship between service and account that I talked about before, if that changes, we can actually change the downstream models at the same time as making this change to the join. So we get to actually, we've got a revisable schema for our data warehouse, our data model, that actually allows us to not have to be so strict in our workshopping on our design on step one, but we get to start doing that as the business asks. So we're setting ourselves up to be flexible as we go forward, which comes to the final point of this before I dive into my own contribution, which is what is the next best action that we can take from this point? So as I'm assessing the steps to move forward for my team, the question that I'm asking is, what can create the most value for the business right now? What decision can we better inform to leave the business in a better place than what it is right now? So when we're standing at Slope Point, at the southernmost point of the South Island of New Zealand, and we're staring at the sign, South Pole this way, the equator one way, we're not aiming to try and land at the equator because we end up with the opposite problem if we land there. We're standing at this point assessing which direction should I take my next step? And there's very little that way, so let's just start taking one step in front of the other. Build something reusable add a field, add a field, add a field, refactor. And that's what's going to take us to a people-focused use of data across our organizations. Final thing, last time I delivered this, I did my segue much more cleanly than I am right now. Here's a thing I made. Because people are first, I absolutely believe that the people in our business know the most about our business, and not all of those people are engineers. Not all of those people are in the analytics space and know SQL, can understand how to put together a YAML file. So over the last few months, I've been working on this tool called Untitled. Coincidentally, ties into the start of this presentation. And this is focused on getting dbt metadata closer to the people. So it's essentially dbt docs, except you can do this. And this happens. You can do this. And this happens. And it's got your lineage. It tells you the Git history of the thing that you've got in front of you. Who created it even from Git history? You can't get that inside dbt docs at the moment. And that is available on PyPy. It's named Tangata, as you see in the top left there. And just pip install Tangata will bring that into your ecosystem. But this is my project. This is designed to pull together. We've got these people out in the business that know stuff about our data. We've got these subject matter experts. If we give them dbt docs, they can't see how to change it. So they might know we've got a better description of this film category name from this weird data set that I found on the internet somewhere. But they want to change it to something that makes more sense. Where did that change? Somewhere in here. Now they can. So it's a piece I'm really keen to get feedback. This is beta. I've built the thing. I haven't built all the unit tests yet, so I'm on a feature freeze while I learn how to create unit tests in Python. But I'd be really keen to get a few of you guys into here and start testing it out. It hasn't crashed on me for a fair while, so I think it's stable. You can add promotion, demotion, other features that I told you, and it all gets persisted into your dbt YAML file. So it's not creating anything of its own. Everything that this tool does is actually just using the dbt pieces. So be really keen to start getting feedback of your use of this and anything that you think I should add as well, because there's quite a lot that I've already got in the backlog to keep moving on here, to keep bringing people that think they can't code closer in to actually being part of the data stuff that we do. That's what really gets me going. And that's everything I had to say.
Well, that is super, super cool. I think this tool is amazing. Easy enough for me to use. So that this tool's really blown me away, because I think that's probably part of the challenge, isn't it, Chris? That sometimes the data team, well, oftentimes the data team becomes a bit of a bottleneck, and the data teams usually they're just reasonably technical, but perhaps not so good at understanding the business context. And there's probably a lot of folks out in the business that can bring that business context, but don't know how to probably code it up in a YAML file or edit a YAML file for that point. Yeah, cool. I will hold my question, but we've got one from David Eldred, who's asked, this will really help close the gap between analytics engineers and analysts and other business users.
Yes.
So more of a comment, I guess. Yeah.
Yeah, it's how can we make the dbt ecosystem easier on day one? Day 180, yeah, sure, you can have a bit of comfort that you can press tab and you will get to the next indent of your YAML file. Day one, that's scary.
Yeah.
So helping pull people across and allow them to interface with us now and then is kind of nice too.
Yeah, nice. One question from me, and you might not have this at the tip of your tongue, but obviously this YAML file generally is checked into a Git repository. You're hosting this Tangata really cool application locally.
Yes.
How do you envisage that Tangata can sort of edit YAML files in a Git repo and perhaps even trigger, like, say, a pull request or something? Is that the functionality eventually that you're hoping to have, or should
I
the
have
YAML
two,
file?
because I am a sucker for punishment, I have two versions of this tool.
Yep.
This is the front end is shared between both. I have two backends. One is pip installable in Python. The other one I haven't been focusing on as much recently is a Node.js backend. I learned React and Node entirely from scratch while writing this. This is hard. I'm 300 hours down. But that Node version is basically can host it. You give it I haven't got a running example. You basically log into your your Git repository. It will pull that down onto whatever server it's running on. It can handle multiple users, so it'll store the Git repo of each of those users' dbt alongside each other. I connected it to dbt Cloud API for something. I can't remember what it was, but it also can do pull requests in GitHub. So that's all in the interface. I'm not focusing on that at the moment.
Yeah.
That was kind of the first place I started, and I thought, we should really make this pip installable. Let's rewrite the whole freaking thing, which is kind of where I'm at right now. But no, I have created pull requests using this. At the moment, it's really just do your thing here. It's changing your local files. Use your favorite Git client to push it back up and do a pull request.
Yeah, nice. No, I was just kind of envisaging this, as a sort of, a tool eventually when it gets to the enterprise or whatever. So this looks fantastic. And I'm actually keen to see how this thing can grow. And, because I think it'll be a fantastic way that the business can engage with the data, get a bit more hands-on. So
there's two ways this can grow. One of those ways is taking that tool, selling it to enterprise, which is why I haven't open sourced it. Everyone has a dream of making money one day, right? The other is I spoke to Bar, who is the product manager for metadata at dbt Labs. I spoke to her in the last week, and it was about 10:30 at night her time, and she was so excited about the concept of interactive metadata. And I told her to steal all the ideas and put them in if she can. So the other possibility is, let's just make the real one do this too. I'm happy with either of those outcomes as long as we get to just edit the stuff easily.
Yeah, it does sound like it'll be, a great add-on whichever way it works out. So that's wonderful. Really appreciate you coming on at such short notice as well. I think you've offered about end of last week to present this week. So really do appreciate it. We invite your friends along because we're like we know that over in New Zealand, you folks are doing some amazing work with dbt and coming up with some really awesome projects and stuff like that, like Tangata. So we're more than happy to learn from you folks. It's really good stuff. Thanks so much, Chris.
Thanks for the invite.
Cool. So without further ado, I might just do a bit of a shameless plug real quick of DataEng Bytes, just to finish up the meetup. Excuse me. So DataEng Bytes, it's a community data engineering conference. So can encompass a bit of the analytics engineering field. So there'll be a few dbt talks and things like that. Lots of data warehousing, data engineering sort of stuff. You can get tickets. Early bird pricing is $74 plus GST. We're at the Wesley Conference Centre in Sydney on the 5th of October. Melbourne, Wednesday, the 6th of October at State Library, Victoria, in the Village Roadshow Theaterette and Conversation Quarter. So really exciting to be able to host the conference on both days at such two amazing venues. I would just say that, we know that COVID's happening at the moment. There's lots of outbreaks and things like that. If we can't hold the conference on the day, we've got a refund policy and the like. So be assured that that's all good. You can also get an online ticket if you're dialing in, if you can't make it to either Sydney or Melbourne. So that's all good. And I just wanted to say thank you to all of our amazing sponsors, including dbt Labs, for sponsoring this conference. So awesome. Well, that's it from me. That sort of concludes another dbt meetup for this month. We're hoping to host these meetups fairly regularly. So if you'd like to sort of put a talk together, if you've got something cool to share, definitely reach out. We're definitely not hard taskmasters from that perspective. So, just reach out and we can sort of tee something up. But so until next time, it's ciao for now, and stay safe, especially if you're currently in lockdown. All the best. Cheers. Bye.